Welcome to the 13th lecture in module 2. In this lecture, we will continue with non-destructive evaluation techniques, but we will talk about embedded sensors. So, in the last lecture we are discussing about a plane strain condition we have equations f double prime minus zeta square f as minus omega square f by C p square, h x double prime minus h x, h y double prime minus h y, h z double prime minus h z, or minus omega square h x by C s square minus omega square h y by s C s square minus omega square h z by C s square, where C s is given by lambda plus 2 mu by rho C p and C s square is given by mu by rho. Now, the solution of this equation will lead to solution on phi h x, h y and h z, okay, which will be a cos alpha y plus b sin alpha y of E I minus omega t. Similarly, C cos beta y plus d sin beta y E I minus omega t. Similarly, E cos beta y plus b sin beta y E I minus omega t, and G cos beta y plus h sin beta y E I z x minus omega t. Alpha square is omega square by C p square minus zeta square, and beta square is omega square by C s square minus zeta square. Okay. If you look at this equation, there are pairs A to H are actually constants which can be determined from the stress free boundary conditions. At both upper and lower surface of the plate. Let us write down those equations. A C3 sin alpha d plus H C4 sin beta d is 0. A C1 cos alpha d plus H C2 cos beta d is 0. These are the characteristic equations we are writing. B C1 sin alpha d minus G C2 sin beta d will be 0 and B C3 cos alpha d plus G C4 cos beta d is 0 minus E C5 sin beta d plus D beta square sin beta d is 0 minus E beta sin beta d plus D I psi sin beta d is 0 C beta square cos beta d plus F C phi cos beta d is 0 and C I psi cos beta d plus F beta cos beta d is 0, where C1 is alpha plus 2 mu into alpha square plus lambda psi square. C2 is 2 I mu zeta beta. C3 is 2 I alpha, C4 and C5. You can wonderfully see here there are pairs which have been formed, which are called coefficient pairs of this characteristic equation. These pairs are namely AH, BG, ED and CF. These two correspond to symmetric and non-symmetric of Lamb waves. These two pairs correspond to symmetric and non-symmetric of shear horizontal wave. For each of the characteristic equation, one can find the specific value of wave number and wave period, wave speed, and that gives a solution for these equations. Now, the guided waves can be excited by impinging the surface with ultrasonic beam in oblique angle. This can happen or this can be induced by a large ultrasonic sensor or ultrasonic transducer fixed at the wedge. So, this can generate a combination of pressure waves and shear waves into the structure. They can also be alternatively created by comb transducers. Comb spacing tunes the guided waves to its half wavelength. In the recent past, researchers have also used piezoelectric wafer sensors. Okay. These are called as piezoelectric wafer active sensors to generate guided waves. There are some advantages of these sensors. They are very light in weight. It is only about 68 milligram. They are very cheap, approximately about let us say $45 each. They are very simple and thin. Essentially, they are about 0.2 millimeter thick and they are unobstructive to the surface where they are embedded. These sensors provide bidirectional energy transduction, that is from the device to the structure and receive it back from the structure into the device. They operate on piezoelectric principle. That couples the electrical and mechanical variables in the material. Let us say mechanical strain is given by Sij and mechanical stress is given by Tkl and electric field is indicated by Ek and electric displacement is indicated by Dj. Then following equation holds good. Sij is S Ijkl of E Tkl plus D Kij Ek. Similarly, Dj is Djkl Tkl plus Jk and Ek, where Seijkl is the mechanical compliance of material measured at E equals 0, whereas epsilon Jk is dielectric permittivity measured at mechanical stress T equals 0. D JKL is piezoelectric coupling effect. Let us see what is the procedure on which the piezoelectric wave active sensor works. The piezoelectric effect converts stress applied to the sensor into an electric charge. Similarly, the converse piezoelectric effect produce a strain when voltage is applied to the sensor. So, interestingly, these piezoelectric wave active sensors can act both as exciters and detectors of elastic Lamb waves traveling in the material. They can be used as both active and passive probes. Let us see the applications of piezoelectric wave active sensors. 1. They can be useful in active sensing of far field damage using pulse echo procedure, pitch catch method and phased array method. They can also be useful in active sensing of near field damage with high frequency impedance method. Further, they can be useful in passive sensing of crack initiating and location by acoustic emission method. They can also be useful for passive sensing of damage through low velocity impact detection technique. of embedded sensors in comparison to conventional ultrasonic sensors. Okay, let us see what are they. The conventional ultrasonic sensors are weakly coupled because they are connected to the structure through gels, whereas embedded sensors are connected to the structure permanently because they are embedded inside the structure. Conventional sensors are these sensors are resonant narrow banded type, whereas these sensors are non-resonant broadband type. They can be tuned for a wide range of frequency of certain lambda waves. Conventional sensors sense lambda waves indirectly through acoustic waves. By impinging them on the surface, whereas these sensors excite lambda waves directly through in plane coupling. So, friends, we have seen the advantages of in comparison to the conventional ultrasonic sensors. We have also said they are very simple, cheap, light in weight and easy to use. Comparison to these sensors, wafer active sensors, which are useful for guided waves application, the plate equation, which can be used for damage detection under free stress boundary condition. In the next lecture, we will discuss further about the NDE methods, different kinds of sensors applicable to NDE and their usefulness in structural health monitoring processes. Thank you very much.